small design choices can create problems that stay hidden for years. This is what makes enterprise integrations difficult. If you are planning to introduce AI on ServiceNow, your starting point is not the AI model. Your starting point is the platform you already have. I decided the data model, integration patterns, security design, and platform approach. Past decisions determine where you begin, but they do not determine where you finish. You can improve the foundation now.
Welcome, tech leads, developers, and tech practitioners, to Expert Talk, the ultimate space for execution insights and deep tech. We focus on architectural solutions, real-world deployment workflows, and the most detailed technical case studies. In today's enterprise landscape, managing workflows efficiently across fragmented systems is a massive engineering challenge. ServiceNow has evolved far beyond a simple ticketing tool into an enterprise backbone. But building scalable integrations and leveraging its latest AI capabilities requires deep architectural insights. Today, we are joined by Mr. Bui Quoc Khoi, a seasoned ServiceNow specialist with over 6 years of hands-on experience. Khoi has architected implementations and managed services across global markets including the US, Germany, Japan, and Australia, holding key certifications like CSA, CAD, ITSM, HR, and Discovery. In this episode, Khoi will walk us through his approach to ServiceNow architecture, integration strategies, and the emerging AI wave. Welcome, Mr. Khoi.
Hi everyone, I'm Khôi. Thank you for tuning in to Expert Talk today. I have spent a little over 6 years in the ServiceNow ecosystem. I spent roughly half of that time on implementations, building new solutions and taking them live. I spent the other half supporting platforms that had already been running for years. Those two kinds of work teach you different lessons. And implementation teaches you how to build and deliver managed services, teaches you what it takes to live with the result. That is where you see the long-term effect of earlier design decisions. Many large organizations start with ServiceNow to solve one problem: IT service management, HR, customer service, or another workflow. Then the platform grows. More teams use it, more processes move onto it, and more systems need to connect to it. That growth creates a challenge. ServiceNow may become the center of the workflow, but it is rarely the only system involved. Data has to move between ServiceNow and the rest of the enterprise. And that is where small design choices can create problems that stay hidden for years. Let me give you one example. A few years ago, I worked on the integration between ServiceNow and another enterprise system. It ran in production for weeks. The API calls returned 200 OK, there were no errors, and the monitoring dashboard was green. But the integration was writing the wrong data. A business user found the problem weeks later. They raised a ticket and said these records are in the wrong state. This is what makes enterprise integrations difficult. We prepare for technical failures. We add retries, error handling, and alerts. But sometimes the API call succeeds while the business outcome is wrong. If we only monitor status codes, we cannot see the difference. Keep that idea in mind because it connects directly to AI. If you are planning to introduce AI on ServiceNow, your starting point is not the AI model. Your starting point is the platform you already have. Its data, its access controls, its customizations, and its integrations. AI will not automatically clean up a messy platform. It will use what is already there, including the problems. So I will cover 3 connected areas today. First, how technical debt enters the platform. Second, how that debt appears in integrations. And third, why it matters when you add AI. Many people first see ServiceNow as a ticketing tool, a form, a workflow, an approval, and a notification. For a developer, it is much more than that. It is an application platform with shared data, security, workflow, integration, and user interface layers. Products such as ITSM, HR, and IRM are built on those same platform services. This changes how a developer should think. You are not just writing a script for one form. Your code can affect shared data, security, performance upgrades, and other applications. A change that works today still needs to remain safe and maintainable when the platform changes later. One of the first architectural decisions is how far you move away from the standard product. Always stay out of the box sounds sensible, but it is not realistic. Businesses have requirements that the standard product may not cover. Some customization will be necessary. The real questions are, does the requirement justify it? And does the team understand the long-term cost? Every customization has to be tested again during upgrades. It also has to be understood by the next developer and changed when the business process changes. One customization is manageable. Hundreds of undocumented customizations built by people who have left the organization turn the platform into a legacy system. This also connects to AI. Changes to fields, tables, workflows, and user interfaces can affect how Now Assist skills receive their inputs or trigger their actions. A decision made during the first implementation may therefore affect what you can adopt years later. Architecture is also shaped by constraints that are not technical. On one HR implementation in Europe, a Works Council reviewed how sensitive employee information would be used. They made it clear that some HR agents must not be able to access certain information. The platform could display the data, but that did not mean it should. We therefore changed the access model, the roles, the access controls, and the field level restrictions. The protection had to exist in the data layer, not just in the user interface. The lesson is simple. Access control is not something to tidy up before go live. It is part of the architecture from the beginning. This becomes even more important when AI starts helping users find and understand information. This brings me back to the difference between implementation and managed services. During an implementation, the team is focused on delivery. There is a date, a scope, and a go live. Success means the solution works and launches on time. In managed services, the focus is different. The platform has to keep working through upgrades, staff changes, and new requirements. The support team inherits every decision made during the implementation, often without meeting the people who made it. The hardest incidents are often not technically complex. They are difficult because custom code behaves unexpectedly. The reason was never documented, and the original developer has moved on. So write down your important design decisions, including the options you rejected and why. That context is extremely valuable to the people who support the platform later. Now, let us move to integrations. This is where platform becomes visible. ServiceNow provides several options for outbound integrations. You can use REST or SOAP messages or IntegrationHub spokes and actions. For inbound integrations, you can expose scripted REST APIs or receive webhooks. For larger data loads, you can use data sources and import sets. Choosing the tool matters, but good design after that choice matters even more. Each problem I'm about to describe returned 200. Okay, the transport succeeded, but the integration still produced the wrong outcome. The first example is a bidirectional integration between ServiceNow and Jira. Incidents and tasks on one side were synchronized with issues on the other. Bidirectional integrations are difficult because both systems can write data and both can react to updates from the other system. Here is the loop. A record changes in ServiceNow. A business rule sends the update to Jira. Jira accepts it and sends a webhook back. The inbound handler updates the ServiceNow record, which triggers the business rule again. ServiceNow sends another update and Jira sends another webhook. The two systems keep passing the same change backwards and forwards. Every API call succeeds, but the loop creates load, fills the audit history, and consumes API capacity. We stopped it with 3 layers of protection. The first is identity. The integration uses a dedicated account. Before sending anything outbound, the business rule checks whether that account made the update. If it did, The rule stops instead of sending the same change back. The second is correlation. Each ServiceNow record stores an identifier for the matching record in Jira. This helps us recognize repeated messages and prevents retries from creating duplicates. The third is a narrow trigger condition. The outbound rule should run only when a field that Jira needs has changed. It should not run after every update to the record. Identity correlation and condition each close a different gap. Together, they make the synchronization both fast and stable. The second example is the silent failure from the opening. Someone added or changed a status value in the other system. Our mapping did not recognize it, so the script quietly used a default value. The API returned 200, but records arrived in the wrong state. We moved the mappings out of the script and into a configuration table. A new mapping could then be handled as configuration instead of a code deployment. More importantly, an unknown value created an alert instead of silently using a default. In transformation logic, an unexpected value should be visible. Do not hide it behind a convenient default. The third example is volume. An integration may work with 10 records and fail with 10,000. Under load, the remote system may apply a rate limit and return HTTP 429, too many requests. Retrying immediately only creates more traffic. A better approach is exponential backoff. Wait, retry, wait longer, and stop after a defined number of attempts. The work should remain in a queue and continue at a control rate. With IntegrationHub, you can configure this behavior through retry policies. A policy can respond to a 429, a timeout, or another defined condition. It can use exponential backoff, a fixed interval, or the retry after header from the other system. You can attach the policy to a connection and credential alias, so actions using that connection inherit the same behavior. This is safer than asking every developer to implement retry logic separately. There is one important warning. A retry may send the same request more than once. If the remote endpoint is not important, that can create duplicate records. This is why correlation identifiers are also important for retries. One more principle. Keep external calls out of the user's transaction whenever possible. When a user saves a record, they should not have to wait for another company's API, put the work on a queue, use an event, or run it asynchronously. Otherwise, an outage in the external system becomes a slow ServiceNow experience for your users. We have looked at three problems: a loop, a mapping change, and a rate limit. All three can happen while API calls are technically successful. That is why integration monitoring must check business outcomes as well as technical failures. AI on ServiceNow did not begin with generative AI. Predictive Intelligence already used machine learning to classify records, suggest assignment groups, and find similar cases. Virtual Agent added a conversational way for users to interact with workflows. AI search improved how users find information. Now Assist is ServiceNow's family of generative AI capabilities across the platform and its products. In ITSM, for example, it can summarize an incident or chat draft resolution notes and replies, help create a knowledge article, and answer supported questions about an incident. These capabilities work inside the ServiceNow workflow where a person can review the result before using it. The next step is agentic AI that can carry out a sequence of actions rather than only generate an answer. That increases the need for clear governance and human oversight for an operations team. The practical value is reducing the time spent reading and reconstructing context. An agent can review a summary before taking over long incidents, start from drafted resolution notes, or find a similar issue that was solved earlier. This does not replace the work. It helps the person reach the useful part of the work faster. I also want to be clear about my own experience. I have learned about Now Assist through ServiceNow documentation and product demonstrations. I have not implemented or operated it in a production environment, so I cannot give you a first-hand assessment of its performance at scale. What I can share directly is how AI affects my work as a developer. I use AI development tools every working day on a live engagement in a regulated industry. I use them to analyze requirements, draft scripts and documentation, prepare test cases, and explore unfamiliar problems. They are now part of my normal delivery process, but AI does not make the technical or architectural decisions. It can suggest options and help me compare them, but I decided the data model, integration patterns, security design, and platform approach. I also verify that the final solution meets the business requirement and follows ServiceNow best practices. AI supports my judgment. It does not replace my responsibility for the design. The guardrails are as important as the tool. First, a human reviews everything before it is used. Language models can invent ServiceNow APIs or methods that do not exist. The code may look convincing and still fail immediately. A developer must be able to verify the output. Second, client data does not go into an AI tool unless that use has been explicitly approved. I can discuss a general structure or a sanitized error message, but I do not share the client's actual data. Third, generated code must follow the same security standards as code written by a person. Extra privilege is not as acceptable simply because AI produced the script. Outside client work, I also build small projects with the Now SDK using source control branches, pull requests, and an automated deployment pipeline. This helps me explore how ServiceNow development can fit into the same engineering practices used on other platforms. ServiceNow's direction with tools such as Build Agent also shows that AI-assisted development is moving closer to the developer's normal editor and workflow. The opportunity is useful, but review, testing, and platform knowledge still matter. This brings us back to the platform foundation. In the ServiceNow SDK, an AI agent definition includes a mandatory security access control. In other words, defining what the agent can do is not enough. You must also define who is allowed to use it. That requirement reflects an important point. AI governance depends on data security, privacy, roles, and access controls. If those foundations are weak, adding a conversational interface does not fix them. It can make the weakness easier to discover and use. Data quality creates the same problem. Now, Assist uses the information in your records and knowledge content. Incomplete incidents lead to weak summaries. Old knowledge articles lead to old answers. Custom tables without clear meaning provide poor context. Integrations that write incomplete data make every downstream use of that data less reliable. ServiceNow's own readiness guidance recommends reviewing record completeness, resolution fields, knowledge content, catalog items, customizations, and AI governance before implementation. That is preparation work, not an optional cleanup after launch. That is why I did not start this talk with AI. Clean configuration, control customization, deliberate access design, reliable data, and integrations that expose bad outcomes were always good engineering practices. They are also the foundation for useful AI. Past decisions determine where you begin, but they do not determine where you finish. You can improve the foundation now. Start with a narrow use case and expand only when the results are trustworthy. The question is, ServiceNow is a major enterprise investment. How can business leaders accurately measure the ROI of platform adoption? And what are the most common hidden costs to avoid? Measure the current process before you change it. How long does it take? How many people are involved? How often does work need to be corrected? Without a baseline, you cannot show that the investment improved the outcome. There are also three hidden costs to watch. The first is customization. The cost continues after go live through upgrade testing and maintenance. The second is integration support. Teams budget to build an integration, but often forget that it must change when the connected system changes. The third is knowledge loss. When the person who understands an undocumented platform leaves, even a small change can become expensive. The question is, should a mid to large organization build an in-house ServiceNow team or partner with a managed services provider? What factors should decide this? I do not see this as a simple choice between an internal team and a partner. The better question is, which responsibilities must stay inside the organization? Keep platform ownership in-house. Someone internal must decide what should be built and what should be rejected. Also keep the architectural knowledge, why the platform was designed this way and why earlier decisions were made. A partner can provide delivery capacity, but the organization should keep ownership of the decisions. A partner can provide specialist skills when demand changes. An internal team provides business context and continuity. Steady demand may justify a larger internal team, while peaks in demand may suit a partner. Most large organizations use a combination of both. Another question is, generative AI and Now Assist sound promising, but leaders are concerned about data security and real workflow integration. Where should a business start if they want to safely pilot AI on ServiceNow today? Start with a low-risk use case that is easy to review. Choose something where AI creates a draft and a person approves it. Incident summarization, draft resolution notes, or a suggested response are good examples. If the result is wrong, a person can correct it before it affects the user. Before the pilot, review the access model and the data behind the use case. Check whether records are complete and whether the knowledge content is current. Also decide how data may be processed and what human oversight is required. Then measure the result. Did it reduce handling time? Was the quality acceptable? How often did a person have to correct the output? Start small, keep a human in the loop, and improve the foundation before expanding. Thank you everyone for listening. I hope these insights give you a clearer roadmap for building robust integrations and leveraging AI on ServiceNow.
Thank you, Mr. Khoi, for sharing such battle-tested engineering insights today. And that's the end of our first episode on Expert Talk. Don't forget to like and subscribe so you never miss upcoming episodes of Expert Talk. If you have any technical questions for Khoi, please leave them in the comments section below. Goodbye, and see you next time.